Happy Monday, Algebra 1 students. Hope you had a great weekend. Today we're back talking about functions, and in class on Friday we talked very briefly about functions. You should have a Freyer model that you filled in on page 34 that gave you the definition. Function is a relation, so it's a set of ordered pairs, okay? But it has a special relationship. Each input, okay? Each input has a unique output. So you can't have two of the same inputs. Okay? You can't have two of the same x values. In a mapping, you can't have two arrows coming off the domain values. Okay? A lot of words we interchange: domain, input, x, independent variables. Those are all words for the x values, the first number in the ordered pair, or the range, the y values, the dependent variable. Those are words we use for the range. You had some homework to do, and it was very similar to my examples on this page. Determine whether the relation is a function. So we're just going to take a look at a couple here. If I look at my mapping, the key is to look at these numbers. In a mapping, I just think this is the easiest way. In the domain, this is the domain on the left. The range is on the right. Those output values. You can think of a machine as a function as a machine. You put some stuff in and you get some stuff out. When I put in 2, I get out the number 6. When I put in 5, I get out the number 10. When I put in 6, however, I can get the number 7 and the number 10. This is not a function because I have two arrows coming off my domain value of 6. Now, it's still a relation, it's just not a function. Over here in the table, again, you've got to look at these x values. Are they all unique? Yes, they are. This one is a function. Yes, it's a function. Now I want to take a look at the graph here. Now remember, the domain, they're the x values. I'm going to label my axis here. This is the x-axis, this is the y-axis. What do you think about this one? For every x value, there can only be one y value. And if you notice, starting about here, if I would have this number for x, how many y values would I have? I'd have one down here and one up here, so I'd have 2. Or if I had an x value over here, again, I'd have one value up here and another down here. This is not a function, because I can have 2 y values for every x value here. So if I look at this graph, it's not a function. Now, functions are different than relations in a manner of we use different notation with functions, and we call it function notation. And it's just a better way to represent the elements of a function, the domain and range. And let me explain how. This is what it looks like. F parenthesis x. Now we read that f of x. And just in this notation here, I can tell you some things. I can tell you, I want to skip down here, that my domain values are my x values. Every number I put in here for x, those are my domain values. My range values represent the f of x. Okay? So let's take a look. If this were just an equation, y equal 3x minus 8. This is how we would write it in function notation. We would say f of x is equal to 3x minus 8. This is that better way to represent the pieces. So if I want to find the y value when x is 1, I just have to plug in 1. But now I can note that as, if I want to know what y is when x is 1, I would let x equal 1, and then I'd have to substitute in to find what y is. Over here with function notation, I can say I want to know what f of x is when x is 1. I do the exact same thing. I plug in 1 for x. But now I can say f of 1 is equal to -5. And this notation here tells me some more information than this over here. So what's inside, these are the domain values. What I get on the outside, f of x, again, these are my range values, my outputs, my dependent variables. And it's just a different way that we recognize functions. So I want to look at a couple examples because this is what you're doing on your homework today. You're learning how to work with function notation. So I have a couple of functions here. Let me zoom in. I have two functions. I have f of x and I have g of x. And here's the deal with function notation. I don't have to use f. I can use g, I can use h, I can use any letter of the alphabet. I wouldn't even have to use x on the inside. Okay, but I do. All right, I know that f of x is equal to -2x minus 3. I want to find what f of -1 is. So what I'm going to do is I'm going to plug in -1 everywhere I see x. What's that called again? I'm replacing x with -1. This is substitution. So I take -2 times -1, that's +2. 2 minus 3 is -1. So f of -1 is -1, and I could write that as an ordered pair, -1, -1. How about f of 3m? There we go. I'm not using x. Well, again, I'm going to substitute. Everywhere I see x, I'm going to plug in 3m. So f of 3m is equal to -2 times 3m minus 3. And I can finish this up by multiplying. This becomes -6m minus 3 is f of 3m. And I can't do anything else beyond that. I don't know what m is. Right? Let's practice with g of x. G of -2. Okay, so everywhere I see x, I'm going to plug in -2. And I've got to be careful here. I would put it in parentheses because we've talked about this before, right? -2 squared is +4. 5 times -2 is -10. So I get g of -2 is equal to -6. Is that right? Okay. Questions? All right, that's what you're doing on your homework today. And there are some challenge problems. So if you have any questions, please put it in that Google document, Alg1 Unit 3 questions that I have shared with you. All right, have a great day. I'll be back on video tomorrow, and I will see you Wednesday. Bye.